Hi, in this video, we'll take a look at another example or another version of the given information to calculate the portfolio return and the risks. So sometimes we're not given the covariance, but rather we're given the correlation coefficient for the returns for two different stocks. But we can always interchange correlation for covariance. So if you remember from the statistics, the correlation coefficient, or rho here, is simply the covariance between two variables divided by the product of their standard deviation. So the correlation is calculated this way. So if we're given covariance or correlation, it is almost equivalent. Okay, so we only need to pay a little more attention to the actual calculations for the variance of this portfolio here. Okay, so how do we deal with correlation here? So if you remember from the last video, the variance for the portfolio is going to be W1 squared sigma 1 squared plus W2 squared sigma 2 squared plus 2 times W1 W2 and then covariance of R1 and R2. So in this case, we can substitute covariance of R1, R2 by using the correlation coefficient, which is the rho here. So if we move the denominator here to the left-hand side, then we can substitute the covariance using what we have right here. So instead of using covariance, we can also use the correlation coefficient here. So the variance of the portfolio simply becomes W1 squared, W1 squared, sigma 1 squared, plus W2 squared, sigma 2 squared, plus 2 times W1, W2, sigma 1, sigma 2, and rho 1, 2. Okay, so try not to forget about this sigma 1 and sigma 2 and this part, right? So the rest of it will be very simple. We just need to plug in the numbers again. So if we plug in the numbers and calculate the variance for this portfolio, I've used slightly different numbers here. Okay, so they're no longer equally weighted. So you will see the difference here. It's going to be 0.2 squared, 0.8 squared for the weights here. Okay, so we'd plug in the numbers here and we would have 0.2 squared. Sigma 1 is 0.15 here. Okay, 0.15 squared plus 0.8 squared and multiplied by 0.3 squared plus 2 times 0.2, 0.8, and then 0.3, 0.15, and multiplied by 0.5, which is the correlation coefficient here. Okay, so then you should get 0.0657 as the variance here, and simply taking the square root, you would have the risk or the standard deviation for the portfolio. So which is sigma, our p here, is the square root of 0.0657, which should give you roughly 0.256 or 25.6% as the portfolio risk. Okay, so let's take a look at the correlations. So why do we use correlation sometimes? Because it is strictly between -1 and +1. So this gives us how strong the relationship is. Okay, so the covariance does not describe the magnitude or how strong it is, but here the correlation describes how strong it is, but not the magnitude. Okay, so 1 being the strongest positive correlation, -1 being the strongest negative correlation. By positive correlation, we mean each time they move, they will always move to the same direction. And by the strongest negative correlation, we mean each time they move, they will always move to the opposite direction. And somewhere in the middle, there will be a 0. So if they have 0 correlation, then there is no relationship or anything related to towards their movement. Okay, so this is something that we could use more frequently and more commonly used. Okay, so remember the formula here. So that is going to be 2 times W1, W2, sigma 1, sigma 2, and rho 1, 2. And the first two parts will be the same if you use the covariance. Okay, so when dealing with exercises like this, you should be very flexible. Okay, and try not to mix them up. and see you in the next video.